So if I look at this next question on the next slide, okay, I'm going to quickly do this one simply for the sake of time. I guarantee you, I'm almost willing to bet you your money back, almost, that you are going to get a sum like this in the exam. Because teachers love it. We love it. And those of you that have written a trig test or exam says, I've seen this one already, sir. Now we can make it funky, we can make it p, we can make it 1 minus p, we can make it roots in there, it really doesn't matter much. But the question is, given that cos of 61 degrees is p, so cos of 61 degrees is p, determine sine of 209. Now, what usually happens in these kind of questions is one of two things. Either kids know how to do it or they freak out. And the freak out usually means, so let me just skip to the next question because I don't have a cooking clue what you're asking me. What is step 1 of any trigonometry? Get angles between 0 and 360. What is step 2? Get angles between 0 and 90. Guys, even if you don't know what the heck you are doing, just do that. You will score half of the marks even if you've got no clue what to do. So in this case, even if I don't know what to do, it's between 180 and 270. So it's third quadrant, so I'm going to go 180 plus 29. Is sign positive or negative there? It's negative. So I'm going to go, well, negative sine of 29. And I'm already scoring a mark. Now, what obsession do I have? Get the angles the same. Is there any way that I can get 29 and 61 as the same? Yes. They add up to 90. So I can say, okay, I want a 61 in there. So I'm going to say, well, this is cos of 61 degrees because those add up to 90 degrees. But cos 61 is p. So my answer is negative p. So if you read the question correctly, it says get the answers in terms of p. It means your answer must just have p's and numbers in it, not trig identities like tan of 20, or they want p's and numbers. That's what they're looking for. So I've answered the first question. Okay, so there's A. So let's have a look at B. This is now kind of where you guys start freaking out. But, so what is step 1? Yes, you, looking behind you, yes. Yes, thank you. Get the angle between 0 and 360. So if I look at 1 over sine negative 421, I'm going to add 360 and I'm going to add 360 again. So I'm going to add 360, I'm going to add 360 again. And this is going to give me, let me quickly do my maths, sine of 299. Okay. Now my angles are between 0 and 360. Now next step is get angles between 0 and 90. So I'm going to say, well, this is in the fourth quadrant, I mean. So it's going to be negative sine 61 degrees. My obsession is satisfied. The angles are the same. But the problem is, I haven't answered the question. Because the question is, in terms of P. Now, some of you, bright sparks in the class, might come and say, but sir, I can change sine into cos. Congratulations, but you'll be further away from the problem. Because then your angles won't be the same. Would I then do it? No. I wouldn't do it because I've already got the angles the same. So now we go through the process. Look at the way that I approach the sum. I don't just run headlong into it. I go, I need to do it without a calculator. There's no special angles. There's nothing that can divide away. I've got to get a triangle involved here. So where does my triangle randomly appears from? From this. Oops. From that. Now, I know that this is some funky magic for some of you. That's fine. I'm going to have a look. Cos 61 equal to P. I'm going to try and manufacture a triangle. Do you see a triangle, sir? No. But I'm going to ask you, what is P divided by 1? P, you agree with me, right? So I can make this P over 1, which means in the triangle, this can be adjacent and that can be hypotenuse. So there's my triangle. For 61 degrees, I've got adjacent, I've got hypotenuse. Can I now get opposite? Well, yes. I can use Pythagoras. So I can go and say, let's call that x. So p squared plus x squared must be 1 squared because of Pythagoras. So x is the root of 1 minus p squared. So what happens? Sine of 61. Oh, but I've got a triangle where I can get anything about 61 degrees. Or if you are one of the smart guys in the class, you can quickly go and say, oh, but sir, this is 29. So I could have calculated sine of 29 by looking from that angle. Your choice. So if I look at this, sine of 61 is opposite over hypotenuse. So it is root 1 minus p squared over 1. But the over 1 doesn't really matter much, does it? So there's my answer in terms of P. Have I answered the question? Yes. Now, ladies and gents, you can try the C1 on your own at home. And you're going to laugh when you see how easy it is. You're first going to go through step 1, step 2, and when you get to step 3, you're going to be like, oh, sir, but it's easy. Once I've drawn up a triangle. Everyone all right? Any questions? Yes. You mean to rationalize that any further? No. Really no. Okay, you've got to understand also the question. The question is not simplify as far as possible. They just say express your answer in terms of P. Does my answer have P's and numbers in it? Yes. So that's my answer. Because the thing is, we do not in this sum try and see, can you maybe, simplify by some algebra? No. We're trying to see, can you relate in terms of P? Okay, everyone's all right with this? Okay. Not really intensely difficult when you start getting used to it, honestly. And guys, we can make this anything. I could make it root 1 minus P. I can make it K squared over 2. Well, whatever. If you draw up your triangle, life becomes easy. Okay. Now, ladies and gents, I'm going to move very quickly on to my favorite section of trigonometry. Proving of identities. I know it's not a favorite amongst my students. I already see some of you giggling, going, no. Okay? But I'm going to give you guys 5 minutes. This is question 3B in your notes. Okay? Just want to make sure. Is it question 3B? Yes. There it is on page 25. Question 3B. I just quickly want to add, I forgot about an identity earlier. My apologies. I just quickly want to look at this identity. Sine squared theta plus cos squared theta is equal to 1. Now remember, and please, heads up before you run into this thing, guys. Before you run into this, put a stop to your pen. Remember this for grade 12 specifically, because every grade 12 year I try and catch my grade 12s out. You do not, listen carefully, want to make a sum larger unless you've got no other choice. So please, now that you remember that this plus this equal to 1, do not every time you see a 1 in a sum, substitute this thing in. I promise you are going to get further away from the problem than when you started. Because this one as well I can rewrite to be sine squared is 1 minus cos squared theta, or that cos squared theta is 1 minus sine squared. The same thing applies. Now that you know it, don't every time you see a sine squared want to go and substitute 1 minus cos squared. Guaranteed, you're going to get further from your answer than you want to be 90% of the time. But if I see this, I'm going to change it into that. Because it makes the sum smaller. Remember that. Remember that for grade 12, guys.